Welcome to the LangChain Meetup, and also welcome to Grammarly. You're at the Grammarly New York City office, and I'm not going to get too much into intros. Just going to get straight into the presentations, and we'll hopefully have some time for a Q&A after each presenter. Again, my name is Al. I'm going to pass it off to Radi Pisakhov. He's going to talk about some of his projects that he's working on. Oh, yeah. Okay. I just want to click this on.
Okay. Hi, everyone. My name is Radi. Thank you so much for coming today. Start. Okay. Hi, my name is Radi. I'm happily married and proud of parent of two beautiful kids. I currently work as an analyst in credit risk personal loans at Citi. I have a degree in economics at Columbia, but I've always loved physics. So I wanted to learn physics of markets. I'm also a founder of Econ Vision. It's a project that helps Columbia students interact with economics models. I was fortunate to intern twice at NASA, not on rockets, but more on data analytics and development application. In my free time, I enjoy coding, learning from others, and experimenting with AI. These days, my focus is on building an AI-driven hedge fund inspired by the movie The Big Short, where Michael Burry sat staring at a screen, observing the crash of 2007. Today, I want to share one of the most interesting tools I've built in my personal project. I picked this one because it's easy to apply to similar use cases, and I'll walk you through some failures and successes I had along the way. The tool is called Edgar Tools. It's an open source project that lets you interact with SEC data using simple code functions. So this is the documentation. It's a very powerful, very maintained by a great community. With the help of Rich and Pandas libraries, Edgar Tools make it really easy to navigate and access free filings. The Python library had great documentation, and on top of that, I've added a simple React agent with multiple tools. Okay, so here you can see I just put the Edgar Tools with the line graph. The only inputs for the agent is the business question. It can be simple or complicated, and a task ID that is generated randomly. And the agent has multiple tools. The first one, it's a retrieve from memory. It retrieves using a RAG system for successful code in the past. I'm using Context 7. You're probably familiar with that. It's an MCP, very well known for up-to-date documentation, specifically for Edgar Tools and Pandas. Knowledge lookup tool, it's a just hard-coded document that I've crafted to get started with the simple functions. A Python sandbox tool, it's a code executor for executing the code agent. And deep dive documents has 4 different actions like saving, searching, listing, and analyzing. So not only you can write the code, it enables to download a lot of the filings to your local machine, and you can scan through it and searching different keywords, extracting from there. And summarize a report. This is something that I found it very helpful because the messages will clutter up with a lot of information, and just created this summarized report that the only argument that goes inside is key findings, and then it's able to make some summarization. And saving memory tool, it just checks the business question and the final report and the summarization output and sees if it really find exactly what we asked for. And if it is, it just saves the code that it executed successfully in the RAG system. So this is how it looks like. It's very simple, pre-built React agent from LangGraph, not really complicated. It's mostly focused on the tools, and I'll show you how it works. So here is the input. There is a business question, there is a task ID. I'll use this simple business question. It's a analyze Apple's latest 10K filing for revenue trends and key business risk over the past 3 years. And we'll start spinning it. And over here, we can see it's starting to do the memory retrieval. From the memory, found two similar searches in the past, and we'll go and start using all different tools until it achieves. It takes some time. I'm not using the fastest model, but probably one that is most reliable and not going to crash here. So from analyzing data to automating prompt engineering, this prompt generation, I want to go through some. So while our Edgar tool is running in the background, I'd like to share one of my experiments. At the end, I also provide the code repository so you can try it yourself. The motivation for this project, which I called Adaptive Agent, came when I realized I was spending a huge amount of time crafting system prompts. And that's how I call it. It's a minified version to one I actually use for you to test and try it out. It's basically a LangGraph workflow that generates its own system prompt based on a user requirement and guidelines with a pre-built LLM as a judge. There is a great project called Leda, also known as MemGPT, as you're familiar with. They created an amazing agent with memory and multiple tools. Their out-of-the-box system prompt is shown here horizontally. I didn't really expect anyone to read it in detail, so I just put it sideways. The truth is, crafting system prompts takes time and practice. Embedding variables, adding metadata, writing tools, usage instructions, even including reading guidance. After realizing how much time it consumed, I thought, why not to let the agent write its own system prompt? And to keep it accountable, I built an LLM as a judge since I'm evaluating the outcomes anyway. So that's how the workflow works. Adaptive agent initialize. You just initialize your model, the list of tools that you want, and then it's wrapped with the adaptive agent class. This is just a simple React agent. If you set up the parameter to 0 attempts, so you don't want to improve or optimize your prompt, it's fine. It will just perform the React agent and it will go to the end. But if you set up some optimization, it will go to this right side hand. So that's how, after you initialize, you just tune it. You just put the initial prompt. It can be very simple, like you're an assistant. You provide him a task. For this example, we'll ask him compare current weather in New York City and San Francisco and recommend which city is better to be in right now. And evaluating system prompt, it's your evaluation for the orange block. It would evaluate how it wrote your system prompt. Expected React final response is the brown block over here in the bottom. You can give some criteria how you want the final response to look like. And the purple tool messages, there is a built-in hard-coded criteria how it thought and how it really reasoned to the tool calling, and you can evaluate that as well. And of course, everything can be customizable. There are some configuration, for example, the thread ID, and with bypassing the limit for LangGraph 25 iteration to 100, it can be also customizable. And max attempts 3. Let me. Okay. So let me see how the Edgar is doing. Okay, Edgar is still running here, but we'll spin up so here we're spinning the adaptive agent. So you can start seeing here the prompt is, you're an assistant. It called 2 different tools, one New York City and San Francisco, to use real data. And it goes and evaluate. It failed all the tests of chain of thought, response, and the system prompt. In yellow, you can see the system prompt that you wrote, and it runs it again. And then it went and failed again, but in most cases, it works, and it writes a very beautiful prompt, and it wrote the prompt again, and it will go and evaluate one more time. And you can test it with different models and different evaluation. So right now in the mode, you can see over here, we put in it, it's initializing with the generic prompt. But if you want to use the one that saved, you just change it to continue, and then it will go retrieve from memory the system prompt that actually passed, and it will be used. And here it went successfully, and here they failed all the tests, but you can try it your own. It worked in the past, but here, of course, it's not going to work. And then gave probably the answer that I was looking for, and the best place to be here right now, it's in New York and not in San Francisco based on the weather. So let's see how our Edgar tool works. And okay, now it goes to again in the iteration. Here it performs some code agent, and it just writes its own code. It will save some. Where is that? The purple one. The purple is saves doing the deep dive documentation. It really saves the markdown files in the system and is able to scan and find these different keywords that you ask in the business question. And there is no really a limit to it. You can download hundreds of files and scan all of them and go through it. So it can be a very long process, but it would go and try to get the most accurate response for a business question. And let's go back to things. So the things that I've learned and I would like to share for stuff that I've built, I focus on non-Gen AI first. You want your application to be very robust before you putting AI. I spend a lot of time to go back and forth, and it's better to have good foundation for your application before you putting your AI infrastructure. Don't stick with one LLM provider. Test multiple, including local models. There are some very phenomenal and very lightweight. Build LLM and embedding model management. This is something that I did early on where I can switch between models, embedding models, and it's very useful when new provider release new models. So you can really switch between models in your applications and the different branches of your use case. Also leverage low-level frameworks like LangGraph, LangChain, Pydantic, and there is a few more because there are no hidden prompts there. You can use and customize as much as you want. Structure output is something that I'm using very often. I found something very successful for me, at least, is to embed this code in the system prompt. And even with very small model, it never really failed for me, and you can borrow it. LLM as a judge works better with binary, true or false, not the integers. When you ask him to evaluate 0 to 100, they're very conservative. They will give you 95, and most time they don't want to give you a 100 score. So I found it very useful to use true and false. Avoiding overlay complexity in your LangGraph workflows. This is the more you put subgraphs and a lot of nodes, it's really hard to maintain, but it's also, if you think about it, hard coding your architecture in some way. So you want to avoid all this friction in that. I don't let AI write my LangGraph workflows. I like to sketch it on a fridge or somewhere I can just to look and think about it throughout the day and kind of tweak it. And then I write it my own. The rest I might give to the AI, but this is something I keep it for humans. And I also enjoy revisiting and revising old AI application, and all could be a month ago or 2 months ago. And it's really amazing to see how I did stuff, and I'm realizing that it's not really smart anymore. So it's really amazing. So let's see if where is that? Okay, so it's still running. I promise you it works. I've tried it multiple times. It has some issues and glitches. It's not production ready, and it's never going to be production ready, but it's a very good use case that you can implement for some frameworks or a different application that you do. And back to this. Okay, so here is the repository for adaptive agent. You feel free, take it, steal it, do whatever you want with it. It's for you. So the adaptive agent, you can just plug your own provider. You can use Olama or whatever you want for yourself. But to be honest, don't listen to me. Go build your own project, right? And play with it, test it, and new ideas, and see what it takes you. And remember, just experiment. You might be onto something no one else thought of yet. Thank you. And if you have any questions, feel free. Yeah. Sure. Yeah. The what? Oh, it failed all the tests. So it didn't really optimize it. Yeah, it works. If I will run in a couple of minutes, it's all there. Yeah.
And how long does it take to have 100 recursion? 100 element is 100, right? So how long can it take?
100 recursion is for the checkpoints, for the LangGraph.
Right, if you bypass the limit, that's 100. So how long can it
I usually set to one-time improvement, and it's fine for me. I use it right now whenever I create application with a lot of tools. I'm focusing more on the tools building rather than crafting the system prompt, because I don't want really 100% of system prompt. If it's 80%, it's fine for me. I just want to focus more on full building the application itself. Sure.
More questions?
For what? Yeah.
Anything you learn from that? Because usually of the tools is where you really gain the advantage. So what can you learn on that?
Yeah, there are two that as I mentioned, summary, a tool that really summarizes, give it key findings, because a lot of messages that it iterates through a lot of messages, and there is some contamination with a lot of information in there with codes and findings. You want your tool, the argument that goes inside is the key findings, what it found, and it tried to summarize into some block. I found it really improved the output, and you had less iteration. And because of you have the summary output, right after in the system prompt instruction, it goes and check the summary against the business question that had been asked, and he evaluates it. If we pass all the tests, we'll save the code into MongoDB, embed the business question into Vector for future retrieval. So that was very useful. So the summary, use it as a tool. I found it very helpful. And the saving successful pattern by checking against. And of course, it checks also for duplicates. So you don't want a lot of successful to look the same. You want kind of variation. So it also checks. So if, for example, I ask the revenue for the past 3 years, and I give for the past 5 years, this is a fail, right? So if you gave me the numbers, it went through all of that. So it has just simple evaluation.
Or are you the one taking?
No, there is no human in the loop. It just evaluates itself with the criteria. It checks. There's a few criteria that I outlined for him, and yeah.
Thanks, Radi.
Thank you.
All right, next up we have Igor. He's going to be talking, one of my colleagues from Grammarly. He actually flew all the way from Seattle to talk about his projects, and give a hand for Igor.
Okay, good evening, everyone. We're really glad to have you here. I'm really excited. My name is Igor, and I am security engineer here at Grammarly. Today, we'll talk about our multi-agentic system that we built to help us with the triage of security incidents. Do we have any security engineers here? Okay, that's fine. So basically, what is security incidents triage? It's not quite exactly the same as incident investigation. Basically, it's the same triage that we have during the in IR. So we come to the desk explaining our symptoms, and soon in 5 minutes, usually, we have a nurse that will assess our complaints and will check if our case is urgent or is kind of worth to be engaged more doctors that are specialized for specific stuff. So that's what we use our system for. We want our LangGraph application, our multi-agent system to help us understand if the ticket, if the alert that have been triggered worth us to dive more deep into. So for the next 15 minutes, I hope we'll talk about why incident response is a problem in security space, why LangGraph and other agentic systems, but we love LangGraph, are the perfect fit for that. I will show the architecture of our system, the successes that we learned, some engineering best practices, and of course, our next plans. So why incident response is really tough in security? First, it's a lot of alerts, hundreds, thousands that you have to look into them, because those are security alerts. You're not able to disable them because that's their job. So we have two main categories that produce this noise: false positive and true positive benigns. False positives are alerts that triggered that they were not supposed to. It's because of flaw in the detection logic, it's because of the exception didn't work, and so on. True positive benigns, it's the alert that you were expected to get, but it was triggered because of some expected action. It was, I don't know, flow in documentation, the engineer didn't follow the development flow or the deployment flow, or somebody logged in from the different location, but that they were not supposed to be there, but turns out they were on vacation. So that's the problem. A lot of false positive, lots of noise. It's very time intensive. So we have hundreds of alerts. You have to look into them. You have to double check them, and they have to cross check with different sources and get the data from different contexts. And turns out the engineers don't like that. As every human being, we don't want to spend time on useless things. And they're not useless, but it's annoying. You're 99% sure that it will be true positive benign, and it's okay, but you have to cross-check them. You have to double-check, because one of those alerts might be a real incident, and that's important. So how effective triage would look like? So first, we need a centralized place when we can add all this context to look at it and to analyze. And also, we want to adopt it dynamically. Someone will say, you can fully automate. Yes, but you have tens of alerts, tens of detections with their own logic, with their own exceptions. And you can just start to add simple scripts on top of it. And if you start to add, you start one script on top of another, and it becomes, instead of reducing the noise, you add more noise. You add more burnout to your engineers maintaining all this stuff. It's also the problem, usually automation is not context aware from different sources. And if you want to add the one source, you get completely different results. And it's not so easy to marry them. They don't know about each other, different formats, different types. So yeah, that's also a problem. They don't remember. You have the script. The one thing that you can add is just exceptions. That's all. It will not self-heal. It will not learn from the past executions. So it's also a problem. The audit, the tracing there, it's awful, because it's a simple script. You will not log there. If you will add logging in that script, you have traces. You will need to dig into them, and that's a pain. And of course, in the security, we need to make sure that the results are trustworthy. And also, we should be able to audit them to make sure that automation worked as expected. And if you didn't find anything, we need to make sure, we need to double check. So why LangGraph? If we compare with traditional approaches, LangGraph, the beauty, it has its state and tracing. So it's very dynamic. We can easily add more nodes depending on the use case. We have conditional nodes that can engage different even subgraphs for specific use cases. And then using the reasoning and LM endpoints, LM models, it's quite dynamic. It's more dynamic and more accessible than simple scripting. It's transparent. You can use LangChain, LangSmith, Great product for the traces. You can use other open source and other audit models tracing. For example, we use MLflow from Databricks. You can store them locally. You can store all these traces in Databricks. And that's only 2 of them, but there are a bunch of them. I highly suggest to look into them. And of course, you can build all the system and run in parallel. There's no scaling problem in this type of application. And as I said, they're very extensible. And the last one, which we really like, all our journeys start with SCP. So it's really easy to integrate the MCP servers that's out there, built by other teams, by products, and you even can build your own for your specific use cases and add tools, resources, and all this stuff there. Our journey, we haven't started with the LangGraph. So all started with the game. We started with the cloud desktop and a bunch of MCP servers that are already out there, like you can connect. We liked it. We liked that it started to save our engineers time. We move forward. Okay, we have specific tools. We have specific servers that we need also to get this content. We're tired of copy pasting stuff in there. We build our own MCP servers with specific tools that have access to our own data. We liked it. The next one, we got lazy. We liked it, and we wanted to automate all this stuff. And we started to explore different frameworks, agentic frameworks, how to automate all this triage. We tried a bunch of them. I will not name them because it's very subjective. But we lack this control over the flow and some frameworks with pre-built orchestrators, because we looked for the framework which allow us to build multiple agents, not just one big agent that will do all this stuff. It didn't work, not because we don't want to, because we tried, it didn't work. So don't try to create one agent that will do all this stuff and throw it a bunch of context, sense of tools, it will not work, trust me. So yeah, that's how we end up looking into LangGraph, and we like it. Because LangGraph has this native state management. We can control the state. We can control the data that is passed through the nodes and select which data is updated, which data is deleted, which data is transferred. And not always we needed an AI agent for specific stuff. We also have nodes that are simple functions. They really work. And yeah, they have retry mechanisms already built there. They work with a bunch of different models. They're traceable, and the logging there is awesome. That's the high-level overview of our system. So I'll start with the ticket, basically, and the initial data. Oh, it doesn't work?
No, people can't hear you.
Oh, that's the most interesting part, guys. So,
Close to that.
yeah, okay. Okay, we have planning or triaging agent, which will take the data from the ticket, will make a plan or the tasks for the swarm or the other agents that will be handled will handle the specific tasks for triaging the incident. As an example, you have a ticket about something weird happening in AWS. So you need business context about what service triggered this alert. It was by a user. Who exactly is that user? You need to get the raw logs from the CloudTrail, CloudWatch. You also need raw log from your application. It could be in different store. As a security engineers, we also want to add security context there. Is the source IP good or bad? Is the command looks like something malicious or not? So all these things, so all this plan, all these tasks are generated by the parse ticket and setup agent, let's call it. And they're handled and they're routed to the specific agents. We use agents specifically for the tasks that they are good at. One agent will not work, just trust me. And don't throw all the tasks at once. Just make them in the loop. You have a list, store them in the state, and go through them. Have a node which will pass all the tasks to the specific agent. It will take care of it. At the end, we have a synthesis agent, which will take all the data from all the agents and will start to connect the dots. Basically, it will have all the concept there and will start to connect the dots to understand what exactly happened. Okay, here's the data about here's the raw events. here's the data about the business side. Who is the user? Who is the service? Is it QA or a production level of deployment? Why it was triggered? Who else have been engaged in that? Is this person working on the something based on the ticketing system? Maybe he already has a task assigned to him about deploying new stuff, working on S3, EC2, and you see the correlation there. So it's quite easy for the human. So why will spend the engineering time there? If it's not enough, it's not in the diagram, but you can generate new tasks. Okay, I get this data, but it really would be nice to get more details about that service. I didn't get this example. You can create new tasks, send it to the queue, and it will be routed to the right agent. After all this done, all the synthesis have been aggregated. It's too much data for a human. Now in LLM AI era, we have a lot of text. We were tired to reading all this huge report. So we have a report generated, which will have it as an output, a markdown report with the fields, with the section that we're really interested in. We also have an evaluation agent. It serves as LLM as a judge. It checks the report. If it's not enough, it returns it back. Just change these fields, add this data, and so on. And yeah, after that, we have the result. What we achieved. So our triage time, shortened from, that's very conservative numbers. It's really depending on the use case. But basically, we shrink the triage time from 30 minutes, very conservative, to 3 minutes automates. Again, it's not a full investigation. We're talking about the triage to understand if it's worth to wake up our on-call engineer in the middle of the night, because both from accounting are on vacation from another side of the planet. We have full audit and full trace of the agents, how they behave. So it's really just you click on the link, you see the whole flow. You can find exactly the point where your agent started to derail. Which agent does a good job and which agent does not. We also create this detection tuning ticket, we call them. Basically, when you see that alert is false positive. So it was not supposed to be alerted. So it analyzed them, and using the report, we generate this detection tuning tickets. So we are ready. We know exactly what it has to be tuned. And maybe in a quarter, we'll have another system which will take care of that. And yeah, of course, it's parallel scaling. It scales all this. For now, it's in AWS, it's in containers. And yeah, that's not a lot of maintaining there. Yeah, that's tracing and in ML flow. So it's not just a bunch of logs in, I don't know, open source, Splunk, whatever system. You can actually see the tools, the system prompt, the results. You can easily understand and trace. So it's very similar in LangSmith. It's really awesome tools. So yeah, just if you are building them, make sure it's not just optional thing for the future. No, just tracing is very important. You need to understand what's really happening with your agents, because your colleagues that will start to use your system, your leadership will start, why it come up with these results? You can see them. You can see the results and the source of the context which influence this specific decision. Some engineering best practices. Use identity model for the state management, for the types, or yeah, at least type dict. Implement proper error handling. Help your agents recover from the fails. They will fail. They will fail a lot. So don't just return error. Give them context. Help them and to guide them how they can recover from it. If it's a wrong API call, you can include in the error some additional details. Use checkpoint for long-term running workflows. You can use locally. You can use also remote checkpointers, memory states like Postgres and Postgres, I think. Yeah, so there's a bunch of them. Luckily, LangGraph has a lot of connectors. And yeah, track everything. Track everything using natively, using additional tools. That's very important. During the early stage of developing, really use tools that already are prepared and helping you to develop. Langsmith, LangGraph Studio, you can run them locally. And it's easy to debug and to rerun the workflows from a specific point, so we'll not need to rerun from, I don't know, from the beginning. Tests, and also apply the hybrid approach, not just node should be an agent. No, it should not. Use nodes as the steps in your process. If you can use determinism, it's easy to. So that's the case when you just can write a simple script, which every time will do the same thing. That's the way. So implement this hybrid model. Use strong components of the AI and use strong components of the deterministic and simple approaches. What we learn keeps your agents very autonomic. Simple rules, defined objectives, defined type and format of the output, and limited number of tools. Do not throw all the tools thinking that it will resolve somehow. No. Yeah, it's if you know how to implement something easy, scripts, use them. Do not throw AI agents on all the stuff. It will not work. Logging and once again logging. It's very important. It will help you to debug and to develop more faster and with more precise and with higher quality. And yeah, context engineering. Don't think that you will throw a raw event logs, a bunch of them into the context, and you will expect that agents will resolve them. No. Be very careful about that. Be very careful about the context that you are adding in your window, explaining. It should match all the data that you additionally pull through MCP, pull from RAG. The system prompt should be aware. Use tags, use XML, use other things, should be aware. So don't tell AI agent that input will be in JSON, but in reality it's in Markdown. It will confuse it. So it's really easy to confuse them. What are we thinking next? How I said, we really liked it. The next thing that we want to add memory, we want to add procedural and episodic memory for our agents. So they will be able really learn on their mistakes without our help. We will look at them. But still, we also want to add additional information using RAG and also have these knowledge graphs to help them to navigate through all this data, all this context, all these sources of the information, because that's a lot. We throw at these agents logs, business context, technical context, and there's hundreds of gigabytes of data there. And you cannot fit all this in one context window. You need to be careful about what data you put there. And yeah, the more we build, the more we are concerned because we started to like it and we started to trust at least a triage. So we want independent mechanisms that will measure and also will optimize them. With the new cases, you start to add more instructions, you start to add more tools. We want to make sure that previous use cases, that the agent, that the system in general started to resolve good, still doing their job good. So there's a bunch of already libraries, approaches, how to measure effectiveness of the agents. So yeah, use it. Of course, LangSmith already have this, and I highly suggest to look into that. Yeah, I think that's all. Thank you.
One or two questions? Go ahead, take her hands first.
For the agent architecture, can you talk about how you were able to train the different agents, like how the log agents from the context, how the agents talk to each other, like weird join?
They do not. That's the idea. We don't want one agent to do all this stuff. But the agent is aware about the context. You are working on this ticket. Here's the data that you should be aware of, and here's your task. That's all. The log collector should not be aware what business context will do or threat intelligence. It's not his job.
How does the join work? How do you join the results?
The join is already the synthesis agent, which has all the outputs from all the agents.
I have one more question.
Yes.
So, how do you do a prompt injection? Let's say that someone knows that you have this device agent, and where they say prompt injection.
Oh, if someone will not exploit our... Okay, we have some light guardrails here. So just, it will not be very stupid.
Like on that objection, or if the agent has like emergent misalignment, where it's trying to be helpful and decides like false negatives with the thought of the person, and we're trying to be extra helpful. How do you think about real time stopping of a thing if it's a bad decision, and a false negative gets through, or that thing might happen? It seems.
Yeah, we started to trust them, but we don't trust them. Now the system does not have the control over the state of the ticket. It will not close it. It can only escalate. So the human in the loop here is about escalating. If agent thinks that it's a problem, it will ping us in the middle of the night. But it's not now all the tickets from that specific detection.
False negative.
No, we review it.
So you're still using every ticket, and even, hey, this is denied. You're still going to.
Yes, we look through the report. We also double check. So we have also a citation. We have all the sources. Oh, this person is working on this. Give me the ticket. You should give me the citation. I can click on it and we'll double check. But we're not spending time on going through all this. If it's not enough, of course, we do initial triage, initial investigations, and add the feedback. We add a small automation that we can write the feedback on agent report into the ticket. And a separate agent, it's not on LangGraph, it's built in ticketed system. It will collect the report, the response, and will create the agent tuning ticket.
One more question? Yeah, I actually had two questions as well. But basically, so the first one was when you're building these like agents, right? Do you fine-tune them by any chance, or is it prompt engineering?
By tuning, you mean?
Fine-tuning means basically like you train them on some subset of
Oh no,
prompts.
that's only system prompts. We use the big providers LLM models. We don't tune them. We tune them on the level of the system prompt and the context and the tool that they have access to. No, we do not train or retrain the models. No.
And like in your experience, you said use only attach only few tools to each other.
As less as possible. So
like, do you have like in your experiments have you seen like what is a good number of tools?
the industry standard, I think it's 2, 3, or maximum 5. But yeah, we try to. Here's all the tools, and the agent started to ask about the tickets in our threat intelligence. No, you will not find information about me in threat intelligence channel. No, just so it's also confusing about the name, description of the tools. So yeah, be careful about that. And also the instruction in the system prompt, what the tools and for that they are used.
Thanks, Igor. I'm sure he'll stick around.
Yeah. My LinkedIn should be in the.
Oh, if you want to connect with Igor, the Luma page has.
Yeah. So feel free to send me, I don't know, questions if you want, what you like, what you not. Thank you. Oh, yeah.
All right. All right. Can you guys hear me? No. All right. So Igor was talking about some very serious production ready LangGraph applications. I'm gonna go in the opposite direction and talk a little bit more about experiments I've been doing while working on and just like toy applications. And my name is Al. I work in engineering operations at Grammarly. And one of my projects is actually helping think about ways we can educate our whole company about how to use tools to be more productive. And so it's given me some freedom to experiment with tools like LangChain and LangGraph. And if you were to ask me 6 months ago, I was going to host a LangChain meetup, I would have said, what's LangChain? I went to another meetup earlier this year where someone was talking about LangChain, and that kind of got me into the rabbit hole, and here we are. So I'm going to talk about two projects. The first project is Agent Inbox. This is actually from LangChain's Ambient Agents course. They have a whole academy on how to learn different techniques and strategies and code for how to build agents. And I'm going to talk specifically about how you can change user preferences over time by providing feedback to this Agent Inbox. So at a high level, what Agent Inbox is, and actually we should have connected, but he's going to talk more about this overall, but it's like a way that allows you to, it's an application that triages your email and lets you know when an email requires you to take action. So someone's asking for a meeting, someone's asking for help, it's going to notify you of those emails and does it similar to the triage. As you can see, most of my inbox in Grammarly are just like these notification emails, which I don't have to respond to. Most of my emails is notifications from Slack or from Confluence and whatnot. And this is a high-level schematic. This is just pulled straight from the repo for the project. And you have a LangGraph agent. There's an interruption for when the human has to get involved. And then the human approves the email to be sent back to the sender. And I want to focus specifically on this part of the application, which is the memory, which I found to be the most interesting part of this application. So when we talk about ambient agents, I was like, oh, what does ambient mean? There's some kind of special technology or system that's doing this. And it turns out there's just like a LangGraph client that has a cron service, and you're basically running cron jobs. And in this case, it's every 10 minutes. So every 10 minutes, there is a cron job that ingests my Grammarly Gmail that pushes to the deployment on LangGraph platform. And then from there, if I look at the traces for that application, I can see like when the cron job ran to ingest my emails, and then also to run this whole like triaging thing of, does this email require my attention or is it just like a notification? So this is, if you're in the Agent Inbox application, this is all open source too from LangChain. When you click into an email that requires your response, you'll see something like this. So in this case, you notice I sent myself an email saying, how can I upgrade my account at Grammarly? Can you send me instructions? So the application correctly identified this as, oh, this requires Al's input. Let's surface this as something he needs to respond to. And there's just some metadata about the email. And then in the application, you can basically, it drafts a response for you. But down here, you can respond to the assistant telling it to use a certain tone, certain style. And I said, add more Gen Z slang to the response. And of course, the LLM responds with a more kind of Gen Z response. And then you can, of course, edit this as well before you accept the edit. And then that gets sent back to the sender. So this to me is the most interesting part, because on the back end, when I put in a preference for how I want to respond in a more Gen Z slang, on the back end, there's a tool call that gets the user feedback, which is me, and it says the user feedback is, we have to incorporate his feedback into the email. The feedback is use more Gen Z slang, and if there's anything related to calendar invites, always tell the sender that he will only meet if the other person wears a red hat. So this is just like this random feedback I was trying to provide to test the system. And then here's the response, another tool call that actually sends the email to the sender with my preferences. And I think this is just using the standard memory store in LangGraph. This was the system prompt. This is just like a text file in the application. This is a system prompt that came with the repo. So generic, like, here's how you respond to an email, be professional, blah, blah, blah. But then as you are providing feedback to the application, the LLM reads your feedback and appends that feedback as instructions to the system prompt. So now the system prompt just constantly gets appended more preferences from me as I'm responding to the emails. And you can see that the way the model is incorporating my feedback into the system prompt are things like always tell the sender that they will only meet if you wear red hat, always use Gen Z slang, blah, blah, blah. And so it's just an interesting way, because if you use ChatGPT now, you know how like it knows how you like to write memos from a month ago. That's because it's keeping user level system prompt about how you like to write memos, PRDs, and whatnot. And that same kind of technology or some kind of workflow applies to this agent inbox memory feature. So I just thought it was interesting to be able to dig into the guts of how memory actually works for this specific agent inbox application. The second application I've been playing around with is a little more experimental and interesting for me, is how an application can continuously learn and optimize itself to be more reliable and provide more high quality responses. And using a simple customer support assistant with RAG based on Grammarly helps in our articles, using Grammarly stuff, somewhat work related. This is a high level schematic of the application, simple kind of workflow. Customer support query comes in, classify the query as technical, as non-technical, do some RAG, generates a response. And the most important part is actually this send feedback thing, which I'll talk about in a bit. So I learned about this open source project called TensorZero, and basically this application is a LangGraph application built with TensorZero, open source, and at a high level, this is from the repo. They say it's an open source stack for industrial grade LLM applications. And the main feature I'd say of TensorZero is this gateway. It's like super low latency. You can access multiple LLM providers through this gateway. And there's a bunch of other things, observability optimizations. It's supposed to be this all-in-one observability monitoring, and most importantly, an optimization tool. And that's what I want to dig in today. So at the heart of the TensorZero project is a TensorZero TOML file. And instead of encoding which models to call, which functions to call inside your LangGraph application, there's a config file where all the functions, models you use, embedding models, all that's encapsulated in a config file. So the whole config as code dynamic. And as you can see here, even like your functions are defined in this TOML file. And this generate response, that's the node that actually generates the response back to the customer when they write in with the customer support query. And so we're going to dive into this generate response function a little more. I think it is similar to LangGraph. You can also have structured output. So this is actually the output schema, just a JSON file indicating how I want the output to be returned from the model. And right, so these three things I highlighted here are for that same generate response function, but notice how I have different variants for models I can call. And so if you were to do this in LangGraph, you'd basically be writing this in the actual main.py or whatever in the node code. But here, all that's defined here, and that's important for the optimization step. So I have three different models I'm using: GPT-4o, GPT-4o Mini, and then one called GPT-4o Mini DICL, Dynamic In Context Learning. And this is the really interesting one I'm going to talk about in a bit. So the generate response function, this is all it is. Like when you call the function using the TensorZero client, you put in a bunch of parameters, and then behind the scenes, the TensorZero client class has this actual request through the TensorZero gateway that actually makes a call to the model. And over here, you can see this is where if there's a variant defined in that TOML file, then it will call that variant to use that variant, GPT-4o, 4o Mini, 4o Mini DICL. So it's like neat to be able to just like quickly write a function that is able to call these different models really quickly. This is like more of a personal preference, but to write this in LangChain, you're putting it all in one file. And I think with what TensorZero is doing, it kind of just has this whole separation of concerns where your code is mostly just business logic, but then all the LLM model is abstracted to that TOML file. So you're just generating one function to make the call. And then like with each in that TOML file, you have a mini Jinja template, which basically corresponds to the system prompt used in the call. And finally, you can also define the weights to use for these different models. And I here putting a weight of 1, which means I want all the traffic going to my application to go through this specific variant. And typically we'll see 33%, 33%. So you want to vary which model variant gets the call. And the TensorZero UI, it's pretty simple, I think, to other observability platforms. You have a bunch of metadata about the call, and then down here, this is the feedback I was talking about earlier. This could be an LLM as a judge, and more importantly, it could be an actual human leaving feedback about a customer support response. And you obviously want these scores to be high, and they'll be included in examples to be used in future inferences. So the kind of a quick flowchart of how this application works is customer support query comes in. The LangGraph application accepts the query, and then that goes through the TensorZero gateway to actually make the call, pick which variant to use, how much weight to provide to that variant. And that's encapsulated here. And if it decides to go to this dynamic in context learning variant, there's another DICL engine that runs. And I'm going to talk about that in the next slide. But all of this gets put into a vector store. They use ClickHouse as the vector store, and that also you do all your embeddings there as well. But then the key kind of part about this whole flow is this last step right here, the feedback collection optimization, which feeds back into the gateway so that when future customer queries come in and it goes to the gateway, it's able to take that feedback automatically. And it's like this automated flywheel so that you're not manually tuning prompts, tuning weights. It just takes things from the vector store, applies it, takes the feedback, optimizes things, and pushes it back through the gateway. I think a nice analogy to use is AdWords. I used to work at Google, and I joined in early 2007, and that's before there was this thing called Conversion Optimizer. So at a high level, the way Google AdWords works is you have a quality score, your ad that you're trying to put on AdWords. You have things like ad copy, your landing page. You have a bunch of keywords you're bidding on, your cost per click, and these two variables indicate or help you calculate the ad rank, which is like where your ad shows up in Google AdWords. Before Conversion Optimizer, you're manually adjusting all of these metrics. You're manually adjusting which keywords to target, how much to bid on those keywords, what your landing page is. And since the auction's dynamic, things are changing in real time. And so one day you're bidding $5 for a keyword, the next day you have to change it to $10 because new entrants are coming into the auction. And then in 2008, this Conversion Optimizer tool came to Google, and as an advertiser, I can say, I only want to pay $6 per conversion on my e-commerce website. Optimize all this crap for me. And that's basically what this feature did. It optimizes CPC scores, your ad copy, the landing page. So you're not worrying about all that backend tuning. You're just focused on the business metric of lowering your cost per acquisition. And I think that's what I believe TensorZero is trying to do, is taking you away from looking at manual traces, logs, and fine-tuning the prompts. It abstracts that a little bit, and it just optimizes towards certain metrics. So if you're trying to optimize towards a very good relevant response, you're trying to optimize towards lower tokens used, cost. If you're running those kind of optimizations, TensorZero is supposed to optimize those things for you. And so I like to use that analogy because that's when Conversion Optimizer came in, it changed how advertisers approach ranking on AdWords. And so what this dynamic in context learning optimization looks like in detail, a customer query comes in. How do I use Grammarly's citation generation for APA format? Relatively detailed question. Let's see how Grammarly responds. It goes to ClickHouse, the vector store, and there's various embeddings. It'll try to do like a similarity search across these embeddings to find a response that will satisfy the customer query. And so the system prompt is use the following K examples, find the best response, and it pulls in these various embeddings. Now the key thing here is once it comes up with a response, there's a response relevance score. It could be feedback from the human, could be an LMS judge, whatever you want to do. If it's a good response to that customer query, that automatically gets put as another embedding in ClickHouse, so that the next time a customer query comes in that's related to this specific question, APA format citations, it now has the fourth embedding to call or use as an example in the response back to the customer query. So here's like that kind of dynamic in context of the loop I was talking about, where as customer queries are coming in, it's self-optimizing itself to pick the best responses based on these feedback scores that's being provided by humans or by an LM as a judge. And so I tried it out. I wanted to see if it could actually work with my little application. And on the left-hand side, this is the DICL variant. On the right-hand side, this is vanilla GPT-4o. And unfortunately, the responses were similar. The confidence score where it was pretty much the same. And I was like, what the heck? I thought this whole DICL thing was supposed to make things better. It turns out that GPT-4o is pretty good at answering pretty good, complicated customer support questions about Grammarly. And there weren't enough examples in my vector store about more technical specific queries relating to APA citations and all that stuff with Grammarly. So didn't really see much success here. And what I was trying to replicate, this is an example coming from one of the examples from the TensorZero repo, a basic named entity recognition exercise. You have a bunch of random sentences and text, and the goal of the exercise is to create a JSON object of a person list, an organization list, location list, and pull out the objects from this text. And in column E, this is like the ground truth data. This is like the actual 100%. These are the entities from this named entity recognition exercise. And so the goal of the model is to see if they can go through this thing and get something similar or close to this output. This is the ground truth. And this is where the DICL really comes into play. So if I look at GPT-4o from the get-go, it does a pretty good job on getting a 50% job on getting an exact match of that ground truth data. GPT-4o Mini, much less costly, and you can see it also is not as accurate. But then if you look at this one right here, this is GPT-4o Mini, the same model, but with dynamic and context learning. So you're getting similar performance as GPT-4o, but for a fraction of the cost in terms of token usage. And so this is what I was trying to replicate with my Grammarly example, but I couldn't because this, again, back to the bad data and examples. This last one right here, you're wondering, oh, wow, like 78%, great. This is actually GPT-4o Mini using a supervised fine-tuning model. And this wouldn't be applicable in a real-time application because supervised fine-tuning can take a few hours. And this is just using OpenAI's SFT functionality. And so I think if you're thinking about optimizing your applications, it's doing something, and DICL it's quick. It's as fast as just doing a simple model call because you're just playing with different model variants. And so the key takeaway for me was like, if I just apply a simple DICL optimization method to my application, it can outperform GPT-4o or perform as well as GPT-4o at the same kind of cost.
Sorry, you lost me about a minute ago.
Yeah.
You're trying to match these customer queries to certain stock problems you can have. Let's get stock responses. There's embeddings in the vector store that represent this. How do these models get to these responses?
Are you talking about this thing or over the Grammarly thing?
The previous one.
Oh, okay. Oh, yeah. So
Yeah, how does this work over here?
Oh, so what I did, even to get this application running, was I actually just ended up scraping. There's 500 Grammarly Help Center articles, so that became my embeddings, my ground truth. But the problem is they were too generic and not specific enough to like more specific technical questions that customers would actually write in about. And so as customers are writing in actual real support queries and humans are responding with actual detailed responses, those would then get added as new embeddings within my vector store. Yeah. But this example was a more easy one to grok because it's can the model get the same exact output? And that's what this chart is meant to show, is that it can't get 100%, but using different model variants and weights, you can get pretty close to pretty good performance. So, yeah.
I would have thought that the ICL would have gotten a higher score here as compared to ChatGPT-4 because you're learning and also embedding system. So wouldn't that, if the questions had more complicated, it would be more advanced than it?
Yeah, so this was actually just a fixed data set of 10,000 rows. So there's no new data coming in. Yeah.
But if there was very more complex questions and then you learned it, then ChatGPT did because it's not being trained on, the model's already trained. So would your RAG implementation advance that number, the score right here?
In theory, but again, I would apply this model to that same list of sentences. Yeah, I'm not sure. That's a good question. I'm not sure. I didn't think about that. So I'm going to get into some takeaways, and then we'll have Robert speak. Just thinking about we need good examples with feedback That's what this whole TensorZero example is supposed to show. This basically comes down to good evals. And this made me rethink about AI applications are more about a reinforcement learning problem where you're just trying to get the model to, you're trying to just get good rewards and feedback to help optimize the application more. These optimization strategies I'm talking about may be overkill for most applications because if you're not making millions of calls per day, you're not trying to optimize to a certain cost because it might impact your gross margin. You may not need all these optimization strategies. And then just some open questions. It's like, how do you set up a proper experimentation framework in general to ensure consistent human feedback? Because like I showed with my customer support example, who is the one going in and responding, oh yeah, this response was like a 0.95 versus a 0.85. And how do you ensure that consistent standard is applied to all those customer queries? Because that gets fed back into the application. And then, yeah, how often do you tune the model to make sure that it's performing to your certain standard? I think that's it. Oh yeah, thank you. And I'm a very big believer in learning and publishing things, and I built some basic LangChain templates. Scan the QR code, langchainpages.com/template gallery. There are these kind of isolated templates. They're meant to be copied. You don't have to install multiple dependencies. They just work out of the box. So there's that. And then feel free to connect with me on LinkedIn and Twitter. I'm constantly publishing what I'm learning about and examples like this. And thank you so much for coming. I'm going to leave. I don't want to take any questions right now. I want to give time for Robert from the LangChain team to give his presentation. So let's give it up for Robert.
Hello, hello. Can you guys hear me? I see someone shaking his head back there. How's it now? A little bit closer? Okay, cool. Yeah, thank you guys for coming. My name is Robert. I'm a deployed engineer on the LangChain team. Excited to be here to talk a little bit about how we think about ambient agents, what ambient agents are, and to show an example. Al has actually already given a spoiler. It's going to be Agent Inbox, but luckily he covered all of the things that I wasn't planning to cover. So let's get started. I think a useful place to start when talking about ambient agents is, what are they? And a useful place to start when thinking about what are ambient agents is to think about how they're different from normal agents. So I'm sure you guys are all familiar with this interface, which is the chat interface. If you've ever used ChatGPT before, this is what you've been using. It's a very common flow where you have a human, you send a message, and then the AI takes that message, generates some sort of response, and you guys continue to have a conversation. And so under the hood, at a very high level that's oversimplified, the workflow looks like this, where you have some sort of human input, in this case your message, it goes to the agent, which does some processing, and that produces an output. So this is the workflow that backs ChatGPT, Perplexity, Claude, you name it. And so the key thing to note here is that for a normal agent, it's triggered by human input. You always have to send a message to ChatGPT before you get something back. And that's where ambient agents are different. The key factor that's different from ambient agents is that they are run off of events instead of human inputs. So you might have an event from your system, you might have an event from the environment, and that's what kicks off your agent, which is then going to do some processing and produce that result. And so a good example of this is Devin from Cognition, which is an artificial SWE. And what Devin can do is it can monitor your GitHub repo for issues, it can monitor your system for issues and create a PR or solve the issue by itself. And so it's monitoring the system rather than being triggered by a human. And so if you think about the interface, you don't really use a chat interface for ambient agents. In fact, at its most extreme, your ambient agent interface might look something like this, where you have a system, it's going to generate some events, and maybe along with those events, it'll generate some tasks for your ambient agent. That might include some sort of spec that gets passed on to your ambient agent, who is then going to take all of that information, do some sort of action, and modify your system. And that might cause a loop where your system, after being modified, triggers more events, goes back to your agent, and the cycle continues. So in this case, your agent, your ambient agent, would be fully autonomously managing and maintaining your system. But in production, we don't really see that, because on average, you still need a little bit of human oversight if you want to have the reliability to release something into production. So your real system might look a little something like this, where before the agent can actually take an action, it has to get some sort of human approval, some sort of human feedback. So you have this little guy here that will say, this agent or this action looks right to me, or maybe I need to edit this action a little bit before it goes through, before the action can actually modify your system. And so if you think about what an ambient agent might look like in reality, going back to that workflow, it might look a little bit more complicated. It might not be solely triggered off of events. It might also take some human input as well. And so that's one thing to note, which is if you think about ambient agents, you can think about them a little bit as more of a spectrum, where you could have something on the far side of ambience where it only runs off of events. But I think in most cases you'll see in production, it'll run off of both. It'll run off of events, and it'll take some human input. And so now that I've explained a little bit of what ambient agents are, I think it's nice to talk about why do they matter, right? Why do you care? Why would you ever implement an ambient agent over a normal one? And I think a good perspective here is to take the perspective of a user of agents. So let's say you're a business analyst, you're using ChatGPT every day, you're a power user, and you're using it at work. Your day might look a little bit like this, where you have a task that you have at the beginning of your day, and you're going to turn to ChatGPT for help, right? You're going to ask ChatGPT your question, you're going to give it some input, it's going to do some processing, it's going to get an output, and then you're going to read that output, and you're probably going to have a follow-up question. And so then you're going to make another input, and this cycle is going to continue until you've completed for all of your tasks for the day. And so the part that I want to highlight here is that there's a good amount of human involvement here. There's a lot of yellow circles. With an ambient agent, your day might look a little bit more like this, where before you even do anything, there might be an event in your system that triggers your ambient agent to take some sort of action and produce an output. Maybe that output modifies your system and it'll trigger the ambient agent again, except maybe this time it's taking a sensitive action. And so it needs to go to a human to review before it can actually continue and apply its action. In this case, you as the human need to get involved. You need to approve this action, maybe edit it before it can continue and go on with the cycle. And what I want to highlight here is that in this system, if your agent is more ambient than not, there's a lot fewer yellow circles. There's a lot less human intervention needed. You're only called in when you need to provide feedback over a particular action instead of every action. And so if you map this to a chart of your own mental load throughout the day, it might look a little bit something like this, where the more ambient the agent is, the less your mental load is. A lot of your common synchronous agents that have a chat interface require basically single-threaded interaction. I'm sure you guys have had multiple sessions of Cursor running at the same time, but most of the time you're single-threaded. You're working with a single agent, you're giving it some feedback, it's producing results, and you're consistently on that thread to complete your task. And so that's this red line here. You're very engaged with your agent the whole time throughout the task progress. But with an ambient agent, the model looks a little bit different because it's capable of doing work without you being involved. So before you even get anything involved, you might have some progress being made. It only gets you involved when it needs your feedback. And that's when your mental load increases, maybe up to the level of a normal agent. But then once you've committed that feedback into the agent, it's able to then continue on with its tasks. So if you think about the model here of how much mental capacity you have, everything between the red line and the blue line is mental capacity that you're saving for your tasks. And that mental capacity can be spent on managing more agents. So if you're using a normal agent today, there's probably only so many sessions of Cursor, so many sessions of ChatGPT that you're using at once. But with an ambient agent, and you have more mental capacity, you can move from managing a small number of agents to managing whole teams of agents. And so that's really the future that we're thinking about here at LangChain and the model that we're using when we're thinking about ambient agents. And so to recap a little bit about what ambient agents are, why they're different from normal agents, we have this little chart. We can say ambient agents, the main defining feature is that they can trigger without human input. And that means that oftentimes they'll be working in the background asynchronously. And when you're thinking about using them, you can treat them as a teammate that can accomplish tasks independently. On the other side, you have normal agents, which require human inputs to trigger runs. And this means that their mode of interaction is very synchronous. It's continual, and you constantly have to hold the agent's hand to complete the task. So it's a little bit more like a junior report who requires consistent guidance whenever they're doing work. Most agents we see in the future, I think, will fall somewhere between these two extremes, but the more ambient the agent is, the more useful work it'll be able to get done without your intervention. So with that said, the last thing I want to do is to show an example of an ambient agent. And Al has already showed a little bit of it, but it's an agent inbox. And so this is an agent that we like to use. Fun fact, our CEO, Harrison, actually uses this agent for his entire production emails. If you write an email to Harrison and it doesn't make it past the AI assistant, he is not going to see your email. So Al's already covered this architecture a little bit, but the key points are this top row. So again, this is an ambient agent. So what it's triggered off of is email inputs, and it's run as a cron job to continuously ingest emails for the inbox that it's monitoring. Once it's detected that there's new emails to ingest and to run over, we're going to have a LangGraph agent run and process those emails. The LangGraph agent will be able to tell, should I respond to this email or should I ignore it? And if it decides to respond to the email, that's what we consider a sensitive operation. Especially for someone like Harrison, you don't want to just randomly send emails without having a chance to review it. And so we have this interrupt step where Harrison gets the opportunity to take a look at what the agent has drafted and decide if he likes it or not. And if he does, that's when it gets approved to actually be sent out. And so this process here, where Harrison gets a chance to review the email drafts, we have built an entire UI for. So this UI, we call it Agent Inbox, and it's designed to help you know what your ambient agents are doing and when they need help. So you can think of Agent Inbox as an email just for your ambient agents. Whenever they need help, they'll raise a flag, and that will be surfaced here into the inbox as a new email from your agent. And what I'm going to do is I'm going to actually show Agent Inbox running over a test email that I have made. So first, I'm going to show the graph of our email agent. And you can see that it's not a very complicated graph. There's a triage router at the beginning where we decide, is this email worth responding to? If it is worth responding to, we're going to send it to a response agent, which is going to draft our email response. Otherwise, we're going to send it to the end where we ignore the email. And so if the response agent looks a little bit like this, it has some tools involved. But the key factor in terms of ambience is that this start node is run whenever we have an email ingested, not when we have a human triggering it. This email or this agent monitors a test email that I've set up. I've made this test email here. You can see I've sent myself a few emails pretending to be different people for the purposes of this demo. So we have 3 emails here in my inbox. We have one that's a system notification. There's downtime scheduled for 2 a.m. We have one that's a marketing announcement about LangChain's new newsletter, which I would ignore as a real person. And then there's one last one, which is an important email. It's a message from my team scheduling a quarterly review call. And so all 3 of these emails have been sent to my inbox, which is again being monitored by our email agent. And so that email agent has run over all 3 of these emails and decided what to do with them. And so if I go into Agent Inbox, we can see what it's decided to do. Note that in Agent Inbox, there's only 2 emails. And that's because our agent has decided to ignore that marketing announcement, just like I would as a real person. And that's exactly what would happen if your email got screened out of Harrison's inbox. He just wouldn't see it surfaced here. The other one is this notify section. In this case, the email assistant decided that it's pretty important for me to know that we're going to have system downtime at 2 a.m. Maybe it's going to impact my work. And so it's decided to surface that to me, but it's only notifying me because it doesn't think I need to actually respond to this email. And I agree with its assessment. So I'm going to read this email, note that we have some downtime scheduled, and then mark it as resolved. And then finally, this last one is most important. For the quarterly review call, our email assistant has decided that the right thing to do is to schedule a meeting for the call. And so you can actually see what it's decided to schedule and when. So we have this quarterly review call. It's on August 27th at 1600, and the attendee is my other personal email, or work email actually. And so I could decide this looks good to me. I can accept this invite and send a meeting invite, or I can give some feedback. Maybe I think I want to have the meeting a little bit later. So I can say something like, can we make the meeting later? Can we make the meeting 1 hour later? And I can send this as some feedback to our agent. And you can see that now it's going to trigger our agent to rerun and to adjust our times. So you can see that now it's done, and that now, oops, sorry, before it started at 1500, not 1600. Now it starts at 1600 and it ends at 1700 up here. So now I think this is good. I like this meeting schedule. I'm going to click accept. And now we're actually going to send out a meeting invite. And what we're also going to do is we're going to see that our email assistant decides to send a confirmation email to all of the attendees. So again, this is a sensitive operation. So it has once again flagged it to me, the user, that there is feedback needed from me as a human. And so we can see that what it's trying to do is it's trying to send out an email, and it has this text that it's written. So I think this looks pretty good. I can click accept, and it's actually going to send the email for me. So now we've finished all of the ambient agent tasks that I have in agent inbox, which means none of my ambient agents need my help or feedback. And if I look into my actual work email, you can see I now have this new email from my test account saying we just scheduled some time for our quarterly review call. To recap, we've covered a little bit about what ambient agents are, why they're useful, and showed an example agent inbox. This code is all available online as part of LangChain Academy. It's called Agents from Scratch. So if you guys want to experiment with your own email, become like Harrison and have your AI assistant screen out all of your messages, you are free to do. Thank you.
Any questions for Robert?
I'm a little bit concerned about you have cursor on a desktop. I don't think relies on a code for a question that you want to solve. This is the same case for ChatGPT, because you ask arbitrary questions, you can't have a kind of an event that triggers that.
Yeah, so in practice, we see what we say, like right now, most common is hybrid agents. So there are pure ambient use cases like Devin, I'd classify, or our email assistant. But a lot of cases are hybrid. If you think about something like deep research, it takes human input at the beginning, it does some clarification steps, but then it runs a lot of subtasks that are all research tasks that may take anywhere from minutes to hours that it accomplishes completely without any human intervention. So if you think about those research subtasks, those are in a way ambient. And so we think about those agents as a little bit of a hybrid model where you might have some human feedback and input up front, and then the agent goes off for a long period of time to do its work. What's the difference between an ambient agent and a tool? That's a good question. I think this is really definitional because in a lot of multi-agent or supervisor architectures, you will structure the sub-agents as tools. So I think in a way, like the agent really as a term just means that you're giving an LLM more decision-making power in the task. You can call any agent that you want as a tool. So yeah, let me know if that's a helpful answer. Yep.
Not necessarily a question, just understanding how ambient agents work. I'm more thinking in terms of, say, enterprise integration, where let's say you use some data sources as part of your workflow. They could be asynchronous in nature.
Yep.
Have you heard of use cases where ambient agents have been deployed to get those data sources in the fully using the enterprise service bus?
Yeah, there's definitely use cases that we've seen where you have ambient agents take data sources, do some sort of action on them. I think one thing that we've seen, I don't know if Igor is still here, but some like SRE agents are triggered off of incidents rather than like human input. And as part of their SRE workflow, they will gather data from their enterprise data sources and then take some sort of action over it.
Does then the framework also maintain the so-called session or context, which knows that, okay, if I come back with this answer, say, after a day or 12 hours, I exactly know, what the basic this kind of thing.
Yes, this is actually one of the reasons why we designed LangGraph the way that we did. So after every node in a graph, we save the state as a checkpoint along with which node we're going to execute next, which means that we can pause at any given task or point indefinitely without consuming resources. So if you come back 12 hours later, we can resume from that same checkpoint. We can know exactly the context that you had at that point, and we can maintain that continuity even if you had a big break between triggering the task and completing it. Yep.
How it works technically, I'm curious. So something is pulled in Gmail every once in a while, perhaps, and then what does it do? An email that comes in, it turns out some sort of prompt and tells LLM, hey, here's like this message, how would you respond to this?
Yes, that is exactly what happens under the hood. Yep.
Let's say someone crafts a malicious email that you got white on white text and memory poisoning over time, slowly that food to get like drift. Like, how would you like stop that?
So I'm not sure about the memory poisoning over time. I think that's an interesting attack vector that is still novel in how you stop it. But the nice thing about ambient agents is that latency is a lot less important than chat-based models. So everyone complains if you're talking to ChatGPT, like GPT-5, and it takes 5 minutes to respond. The advantage of the ambient agent is that you can take as long as you want generally, which means that you can add guardrails, you can add extra checks, and that makes your agents more robust against a lot of the common prompt injection attacks. I'm personally not familiar with the memory poisoning attack as much, so I can't speak confidently on that one. Do what strategy, sorry? Oh, yeah. You can stop the ambient agent at any time. That's something that you can do in LangGraph as well. If you're deployed on LangGraph platform, you can send like a cancel, or you can send an abort signal as a input to the graph, and that will stop whatever task it has in execution. But that's something that actually applies whether you're using like a normal chat-based model or an ambient agent. Yep.
I have like a question. What do you think where R&D is going next?
Yeah, I don't want to say too many buzzwords, but I think the actual most important thing right now is context management. I think as we get really good at managing memory, passing the right context to agents, you can have agents that run a lot longer and still maintain coherence. One of the biggest challenges right now is that if you have a really long running agent in production, eventually it starts to lose a little bit of coherence unless you do something special to manage what context you're passing to it. And so I think that's the point where we'll start to see more ambient agents in production, because ambient agents by nature need to be very long running. So I do see like ambient agents becoming more common. I think the common driving thread is context management though, and improvements in that sense. Yep.
What do you suggest? Another one is does LangGraph provide or LangChain has any plans in terms of context management? Because right now, LangGraph is context management other than the scratch tag.
Yes. For your second question, yes, stay tuned. We have stuff in the pipeline. We will be releasing it. For the first question, I would say we generally recommend state graph. Functional, of course, is great, but it is newer. We're pushing towards LangGraph version 1.0. And so the oldest version, the part that's gone through the most iterations, is our like state graph. So generally, if you want something a little bit more stable, that's what we'd suggest. Thank you.
All right, thank you, Robert. That's the meetup. Thanks so much for coming, and just stick around and grab some more drinks and just meet each other here. And yeah.